All right, in chapter 6.6, we are going to solve radical equations. And we're going to talk about how it's necessary that you check every answer that you get in the original equation to make sure that it actually does satisfy the equation. All right, so when we say radical equation, what does that mean? That means that we're just going to have an equation with a variable that we need to solve for under the radical. We've done these before, but the ones that we'll do today, they'll be a little bit more in depth. These steps that you follow are super important. You always need to isolate the radical or the expression in parentheses. So it'll just depend on what the problem is. Sometimes it'll have a radical, sometimes it'll be something in parentheses, but whatever it is, you have to isolate it. So if you're multiplying by something in front, that has to go. If you're adding or subtracting something at the end, that has to go. You must isolate. Then you're going to raise each side of the equation to the same exponent to eliminate the radical or the exponent, depending on the problem. And then the last thing, solve for the variable. Again, just like I said at the beginning, you need to check your answer every single time. We're going to have sometimes what we call extraneous solutions, and these are solutions that look like they're solutions, but then when you actually check them, they don't work. All right, so let's try a couple. In this first example, notice there's not a radical, but there is a rational exponent. So I could rewrite it as a radical. I don't have to, but I have to remember that I need to isolate. So that term x plus 2 to the 3/4 needs to be isolated, which means this 1 needs to move to the other side. So I add the 1 over, and I've got x plus 2 to the 3/4 equals 8. Now, if I'm going to get rid of that exponent, I have to raise it to some power. I want the exponent to be 1, so I need to think about what could I multiply 3/4 by so that that exponent turns to 1. You can multiply by the reciprocal. So every time if you have a fraction as an exponent, you're going to raise it to the power of the reciprocal. So I'm going to raise it to the 4/3. Remember our properties of exponents. If I raise a power to a power, I multiply. 3/4 times 4/3, that's just 1. So that gets rid of the exponent. I just have x plus 2 now. 8 to the 4/3, that can be rewritten as a radical, so we use our knowledge from chapter 6.1. The denominator becomes the index, and the numerator is the exponent. And then we simplify. The cube root of 8 is 2. 2 to the 4th is 16. Solve for x. X equals 14. So let's check that. If I plug 14 in at the very beginning, do I really get 7? That's what we're checking to see. So I've got 16 to the 3/4 minus 1 equals 7. Again, this can be rewritten as the 4th root of 16 cubed minus 1. 4th root of 16 is 2. 2 cubed is 8 minus 1 really is 7. So we're good. All right, let's try the second one. I have to get x to the 3 halves isolated, so that means I need to divide by 3 to start with. So 375 divided by 3 is 125. Again, I've got this fractional exponent. That needs to go. To get rid of it, I need to raise that to the power that would make it 1. So the reciprocal would do that. So I'm going to raise it to the 2/3 power. 3 halves times 2/3 is 1. That goes away. Rewrite this as a radical. That's the cubed root of 125 squared. Cube root of 125 is 5. 5 squared is 25. So let's check again. 3 times 25 to the 3 halves. Does that really equal 375? So let's rewrite this as a radical. That's the square root of 25 cubed. Square root of 25 is 5. 5 cubed is 125. So yes, this is going to work because 3 times 125 is 375. So 25 is my solution. All right, let's try this one. Again, we've got something being multiplied in front, and now we have a radical and we have something underneath. I have to get rid of the radical, but I've got to isolate it first. So this 2 has to go. 2 is being multiplied by the radical, so to undo that, I need to divide by 2 on both sides. So I've got the cubed root of x minus 3 equals 2. Cube both sides to get rid of the cube root. X minus 3 equals 8. So we just end up that x equals 11. So we can probably just check this one real quick in our head. If we plug 11 in, we know that 11 minus 3 is 8. The cube root of 8 is 2. 2 times 2 is 4. We're good. So sometimes if they're quick like that, you can definitely check them in your head. If they're longer, like this next one, we're probably going to want to work this one out to check it. All right, so a lot going on here, but I need to isolate these, or this parenthesis. So that means this 22 needs to be subtracted to the other side. So I've got 3x plus 43 to the 2/3 power equals 16. Again, I need to undo that exponent. So to get rid of 2/3, I need to raise it to the reciprocal. 2/3 times 3 halves, that's just 1. So I've got 3x plus 43 equals, let's rewrite this as a radical. The denominator becomes the index, so I've got the square root, and the numerator becomes the exponent. Now here's where we need to be a little bit careful. We're solving, and I just took the square root. That means the index is even. So when I take the square root of 16 is plus or minus 4. This is the first time we've seen it with an even root, so we need to remember plus or minus. So from here, I'm going to write 2 separate equations. I'm going to write one with the positive 4, and I'm going to write the other with the negative 4. So I've got 3x equals 21 and x equals 7. Do 4 cubed, subtract 43 to get this 21. Here I end up with, let's see, 3x plus 43 equals negative 64. 3x equals negative 107. Let's just leave this as negative 107 over 3. I've got two answers that I need to check now. So you do need to check both of them. 7 is going to get plugged back in here to the beginning. 3 times 7 plus 43 to the 2/3 plus 22. Does that really equal 38? So start inside your parentheses. 21 plus 43 is going to get me 64 to the 2/3. We take the cubed root of 64 and square that. So the cube root of 64 is 4. 4 squared is 16. 16 plus 22 is 38. So we're good. So let's check this one. 3 times negative 107 over 3 plus 43 to the 2/3 plus 22. Does that really equal 38? Here, these 3's are just going to cancel, so I've just got negative 107 plus 43. That's negative 64 to the 2/3 plus 22 equals 38. So here I've got the cubed root of negative 64, which is negative 4. Negative 4 squared is 16, and again, 16 plus 22 is 38. So both of those do end up working. So there's two solutions here that are going to satisfy this equation. All right, so let's talk about something called an extraneous solution. This is what we call a solution that doesn't actually end up working. So it's an apparent solution. We think it's going to work. That does not satisfy the original equation. So every example that we've done so far, we've gotten answers that worked. We haven't had any extraneous. For this one though, I'll spoil it, you are going to have an extraneous solution at the end. Now we can't tell from the beginning whether or not we're going to have one. That's why you have to check every single time. So on this one, notice I've got a square root on one side, and we haven't seen it yet where I've got variables on both sides. So that's going to make this one a little bit more interesting. I still have to get rid of that radical though. Notice it's isolated. Nothing's being multiplied in front. Nothing is being added or subtracted outside the radical. So the first thing I need to do is get rid of that radical. To undo a square root, I need a square both sides to keep it balanced. Now here's where you have to be careful. X minus 3 squared, that's x minus 3 times x minus 3. That is not x squared plus 9. You cannot just distribute the exponent. You have to rewrite it as x minus 3 being multiplied by itself. And then the square root of x minus 1 squared, that's just x minus 1. Now I've got x's on both sides, so I have to go through and multiply this and get all of my x's on one side. So if I FOIL this, I end up getting x squared minus 6x plus 9 equals x minus 1. Now I have a quadratic now. I have to solve the quadratic, which means I need a factor, so this needs to get set equal to 0. So I'm going to subtract this x and add this 1. Now that it's set equal to 0, I can factor it. Factors of 10 that add to negative 7 are negative 5 and negative 2. I'm going to say the code word for this video is factoring, since that's what we have to do in this problem. And now if I'm going to solve zero product properties, set each factor equal to 0. So we get 5 and 2. Let's check these. 5 minus 3 equals the square root of 5 minus 1. 5 minus 3 is 2. The square root of 5 minus 1, that is 4, so the square root of 4 is 2. 5 is an answer. Let's try 2. 2 minus 3 equals the square root of 2 minus 1. That's negative 1. The square root of 1 is 1. Negative 1 does not equal 1. So that means 2 is not a solution. The only solution here that works is x equals 5. We can say that x equals 2 is an extraneous solution. We solved for it, we thought it was going to work, but then when we plugged it back in, it actually didn't work because we were off by a sign.